Welcome! If you're getting ready for your GCSE higher tier maths exam, you know probability can be a bit of a minefield. So in this explainer, we're going to build your very own probability toolkit, one tool at a time, to make sure you can walk into that exam feeling totally prepared.
So, here's our game plan. We'll kick things off with the absolute foundational rules. Then, we'll get into the different ways of counting possibilities. After that, we'll level up to tackle combined events. And we'll finish with a really key topic for the higher tier, conditional probability. Let's get that toolkit built.
Okay, let's get right into it. Everything we're going to cover today is pulled straight from the Pearson Edexcel spec, specifically points P1 right through to P9. But we're not just going to list them off. The goal here is to turn that spec into practical, powerful tools you can actually use to nail those exam questions.
Right, first things first. Before you can tackle the really complex problems, you've got to have the basics down cold. These are the foundational rules that every single probability question is built on. Get these locked in, and honestly, everything else just gets so much easier.
So we start with what's called theoretical probability. This is pretty much the maths behind the chance. If you've got a fair six-sided die, you don't actually need to roll it 100 times to know the probability of getting a 4 is 1 in 6. It's all based on that perfect ideal situation where every outcome is equally likely. It's what we expect to happen.
Now, think of this slide as your secret weapon, your built-in error checker for the exam. Every single probability answer you ever write down must be a number between 0 and 1. If you do a calculation and get an answer like 1.5 or a negative number, you know immediately you've gone wrong somewhere. 0 means impossible, 1 means it's absolutely certain. And here's another one of those fundamental rules for your toolkit. If you have a set of events that are mutually exclusive, which is just a fancy way of saying only one of them can happen, and they cover all the possibilities, then their probabilities have to add up to 1. This is a brilliant shortcut for those probability of not something questions. Instead of adding up everything else, you can just do 1 minus the probability that it does happen. So much quicker.
So how do all these ideas link together? Well, it's all about the connection between theory and reality. P1 is about recording what actually happens in an experiment, using things like frequency trees. P2 is about using our theory to predict what we expect to happen. And P5? Well, P5 is the bridge between them. It tells us that the more times we do an experiment, the closer our real-world results should get to our theoretical prediction.
Okay, let's grab our next tool. In the exam, you're definitely going to face questions with 2 or even more things happening at once. The tricky part isn't just the probability itself. It's making absolutely sure you've counted every single possible outcome without missing one.
Let's use a classic example. You flip a coin, you roll a die. What are all the possible combinations? Well, you could get a head and a 1, a head and a 2, maybe a tail and a 5. It's really easy to lose track and miss one, right? So how can we be systematic and guarantee we find every single one? And this is where a sample space grid becomes your best friend. It's honestly one of the clearest and most foolproof tools for this job. You just pop the outcomes for one event along the top, the other down the side, and fill it in. And just like that, you can see all 12 possible outcomes laid out perfectly. No guesswork, no chance of missing a combination.
And that grid isn't your only choice. You've got a whole toolkit for listing outcomes systematically. Grids are amazing for 2 separate events. Venn diagrams are perfect when you're dealing with overlapping groups. And as we're about to see, tree diagrams are fantastic for events that happen one after the other. Choosing the right tool for the job can save you a ton of time.
Okay, we're leveling up now. Let's add a more advanced tool to the kit, one that's designed to handle questions about combined events. This is all about calculating the probabilities when multiple things are happening, and it hinges on one really important distinction. And here it is. This is absolutely crucial. Are the events independent or are they dependent? Independent events don't affect each other at all. Think about rolling a die twice. The first roll has 0 impact on the second. But dependent events do affect each other. The classic example is picking sweets from a bag without putting them back. Whatever you pick first changes what's left, and that changes the probabilities for the second pick. Getting this right changes the entire calculation. And this is a perfect illustration of how that dependency works on a tree diagram. Look at the probabilities for the second pick. They're all out of 7, not the original 8. Why? Because one marble has already been taken out, and crucially, it was not replaced. So the probabilities for the second event literally changed based on what happened in the first event. That is the core idea of a dependent event.
All right, let's get our hands on the final tool in the kit. This is a big one.
and it's vital for hitting those top grades on the higher tier paper. Conditional probability. It builds directly on what we just saw with dependent events, but it often looks a little different in the exam.
You'll very often see these questions start with a two-way table, or sometimes a Venn diagram. This table here neatly organizes all the information about 100 students, sorting them by their year group and which language they study. All the numbers you're going to need are right there in front of you.
Now read the question really carefully. I want you to find the two most important words on this slide. See them? Given that. This phrase is a massive, massive clue. It's a signal. It's telling you that we are no longer interested in all 100 students. That condition has changed our world. It's shrunk the total number of possible outcomes.
So here's how we use that signal. The condition, given that the student is in Year 10, means we completely ignore the Year 11s. Forget they exist. Our universe of possibilities has shrunk from 100 students down to just the 50 who are in Year 10. That becomes our new denominator. And out of those 50, how many study Spanish? The table tells us it's 30. So the probability is simply 30 out of 50.
So there you have it. That's your probability toolkit, all wrapped up. We've gone over the foundational rules, the 0 to 1 scale and the sum to 1 rule. We've looked at systematic ways to count every outcome. We've drilled down on the crucial difference between independent and dependent events. And finally, we've seen how to use that given that clue to handle conditional probability. You've got a tool for every scenario.
You are now equipped with a seriously powerful toolkit for probability. The real skill from here on out is knowing exactly which tool to pull out of the bag for which question. So get practicing, try applying these methods, and you'll be ready for whatever the exam decides to throw at you. Best of luck.